Most people assume that if they aren't currently infected with a pathogen or suffering from a physical injury, they are healthy. But viewing health simply as the absence of disease is a structural misunderstanding of human biology. To understand how the global medical community actually measures human well-being, we have to look at the baseline established by the World Health Organization. Their definition establishes health as a state of complete active equilibrium. It begins, predictably, with a fully functioning physical state, a body operating without mechanical or biological errors. But that physical baseline must intersect with mental and emotional resilience. A body cannot maintain internal homeostasis if its nervous system is continuously degraded by psychological stress. Finally, the WHO requires successful social integration. Humans are cooperative organisms, and severe isolation or hostile environments directly depress our immune responses and overall longevity. Maintaining this three-part equilibrium requires continuous input. The human system relies entirely on clean drinking water, balanced daily nutrition, and strict personal hygiene to fuel its internal defenses. Because true health is an active, ongoing balance rather than a passive default state, it is highly sensitive. The moment those inputs fail, the system becomes vulnerable to systemic disruptors. In medical science, a disease is defined strictly as a malfunction or disorder of normal body functions. It is a point of failure in the system. This flowchart outlines how epidemiologists categorize failures, dividing diseases into two primary branches, communicable and non-communicable. Looking right, non-communicable diseases stem from internal system failures. They don't spread between people, arising instead from organ malfunction, genetic errors, allergies, or nutritional deficiencies. Researchers have mapped internal malfunctions for over a century, attempting to isolate where a patient's cellular blueprint goes wrong, as seen in early cancer exhibits. Returning to the chart, the left branch details communicable diseases. Unlike internal failures, these are external biological threats that physically jump from an infected host to a healthy one. Treating a non-communicable disease involves repairing internal physiology. Treating communicable diseases means repelling a literal invasion. The agents of this invasion operate at a microscopic scale, programmed with a singular objective: to enter a host, multiply, and colonize its resources. This section of the reference chart categorizes these disease-causing microorganisms, or pathogens, into four distinct classes: bacteria, viruses, protozoa, and fungi. Despite their devastating effects once inside a body, pathogens possess a critical physical limitation. Most of them are incapable of traveling vast geographic distances between hosts under their own power. To cross distances, pathogens require biological vehicles. An organism carrying a pathogen to a host is called a vector. Houseflies, for instance, act as environmental bridges. They pick up bacteria from decaying matter and deposit it directly onto human food. An outbreak cannot occur without these specific mechanical pathways. The invisible microscopic pret is powerless unless it has a biological or environmental bridge to carry it to a new host. Scientists call the specific route pathogens take to cross the gap between hosts the transmission chain. This panel illustrates the four primary chains of transmission. First are physical pathways: direct contact through touch, and droplet infection spread by sneezing or coughing. The remaining two are environmental: ingesting contaminated food and water, or injection by insect carriers. The efficiency of droplet infection has driven massive global health crises, forcing populations to implement physical barriers just to navigate public spaces safely. Left unchecked, these chains of transmission flood local healthcare infrastructure, requiring massive isolation wards to manage the sudden influx of compromised biological systems. Tracing these exact routes provides public health officials with the precise data needed to design interventions that sever the transmission chain entirely. To combat communicable diseases, modern medicine utilizes a defense-in-depth strategy. This relies on multiple, overlapping layers of intervention meant to intercept pathogens long before they breach the skin. The first behavioral layer directly targets physical transmission. The routine mechanics of wash hands with soap and covering coughs effectively destroys pathogens residing on external surfaces. Because it is highly effective, standardizing this behavioral layer across the general public has been a cornerstone of global education campaigns for decades. The second layer focuses on environmental control. Disposing of waste properly and draining stagnant water specifically denies vectors like mosquitoes and flies the habitat they need to breed. Together, behavioral hygiene and environmental control form the outer walls of a biological fortress, neutralizing threats in the environment so the body doesn't have to. However, external defenses eventually fail. When a pathogen breaches the host, survival depends entirely on the body's internal biological response. We can artificially prepare this response through vaccination. By introducing a harmless fragment of a microorganism into the system, the body maps the threat and develops specific antibodies without suffering the disease. Deploying this safeguard requires immense logistical coordination, mobilizing millions of civilians to receive prophylactic treatments to stop wide-scale community spread. Yet, at its core, this global defense strategy always comes down to an individual physical intervention, training one nervous and immune system at a time. This technical definition details the ultimate goal: immunity. It is the natural, activated capacity of the body to recognize and defend itself against invading microorganisms. True health is an achieved state. It is the result of continuous effort, a rigorous system of physical balance, environmental hygiene, and biological readiness designed to hold the line against an ever-adapting microscopic world.